Oakland, California, located 100 miles north of Sacramento, is home to a new 1.5 megawatt photovoltaic system. This is the first solar project in the U.S. owned and operated by Enerparc, representing another successful example of the rapid adoption of renewable energy by utilities and their customers. Even though construction of the entire site was completed in just 2 months, in California, due to extensive permitting and environmental requirements, it's not unusual for even a small project such as this one to require 2 years to develop and build. Spanning a 12.5-acre parcel, this system will produce 4,000 megawatt-hours of green electricity each year, enough to power 600 local homes. The site was previously used for dry farming, but produced insufficient revenue for its owners, leaving them open to other potentially more profitable uses for the land. Once an agreement was in place, Enerparc invested in and upgraded the utility distribution network that the system would tie into, improving the efficiency of the grid to move and deliver energy across California. While solar modules are commonly attached to a fixed metal structure facing true south and tilted at an optimum angle, newer technologies allow the modules to be mounted on tracking tables that rotate to follow the course of the sun throughout the day. This approach increases production output by about 20% over the more traditional fixed tilt systems. For its Oakland project, Enerparc deployed a tracking system with a combined linkage design in which the sun tracking is set in motion by a common drivetrain, centrally powered by a few electric motors.
My name is David Fitzgerald, and I am the Senior Project Manager for Enerparc. And I'm here at the Oakland project site where we're building 1.5 megawatts of solar arrays. This is Enerparc's 10th project in the United States. And it's the first entirely developed, built, and financed and operated by us. The entire construction project from the point in which we break ground to completion is going to be approximately 8 weeks. It's just part of our philosophy to do things as quickly as possible and get it up and running.
In order to complete construction ahead of the approaching winter rains, Enerparc employs over 50 regional subcontractors and vendors to install the mechanical and electrical systems. Many facets of the construction work are performed concurrently, thanks to proprietary designs and the tight management of all project participants.
On this project specifically, one innovation that we identified and implemented was the use of messenger wires and cable saddles. This allowed us to install all of our DC string wiring without disturbing the ground. This was important because ground disturbance leads to dust reaching into the atmosphere, which requires additional permits and additional dust control measures. This also accelerated the rate of installation and kept us out from costly trenching and subsurface conduit work.
The challenge of Enerparc's next project, a 3.5 megawatt solar farm near Lincoln, Nebraska, was that the topography of this previously farmed parcel was less than optimum for the implementation of a tracker. So, instead of resorting to heavy grading of the site, Enerparc's engineering team addressed the challenge using single-row, independent trackers instead of the more commonly deployed combined linkage design used on the Oakland project.
We opted for a distributed drive linkage where each table tracks independently of the other, and we didn't have to worry about the site being completely flat. This is highlighted by the fact that you see each table tracking independently and the fact that it's not completely consistent from table to table.
Another unusual design requirement for the tracking system was to sustain heavy snow loads, which in this part of the country can reach 50 pounds per square foot, the equivalent of more than 2 feet of fresh snow. Enerparc worked hand-in-hand with its tracker supplier to design a reinforced torque tube mounted at an elevation of 7 feet to mitigate the impact of snow accumulation around the trackers.
Every single project, we select components that meet the specific needs of the project, and we engineer them for the specific site conditions that are expected. That sets us apart because although we like to replicate designs as much as possible for efficiency and speed gains, we find that every project has exacting needs that need to be met.
The Orland and Lincoln projects are great examples of Enerparc's growing success in the U.S. Managed by an experienced and market-alert team, Enerparc embraces innovation and new markets with new projects currently under construction in Minnesota, Tennessee, and Montana. After establishing itself as a leader in the European solar market, Enerparc is well positioned to become the premier boutique solar investor and operator in the U.S., bringing more environmentally and socially responsible energy to local markets around the country.